All right, so working on radicals. Labeling just the parts of the radicals, the symbol itself is called a radical. The number up here is called your index. And the number underneath is called your radicand. If there's a 3 where your index is, that's the cube root. If there's a 2 where your index is, that's your square root. And with math, you don't even need to put the 2 there, and it's still the square root. And why that is because a lot of the times, the most radical used is the square root. And people just start getting lazy and stop writing the 2. They don't want to write the 2 every single time. Like, here's 5 different questions. I don't want to have to write a 2 up here every single time. You just have to know this is the square root of a number. So to find your perfect squares, like from your warm-up, you do 1 squared, you get 1. 2 squared, 2 times 2 is 4. 3 squared is 3 times 3 is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 49. 7 squared, 8 squared, 64. 9 squared, 81. And 10 squared is 100. And then using these numbers, you have to have these numbers, know these numbers at least. We can do some examples. The first example we're going to do is the square root of 81. And I know actually some of you just know the answer, the square root of 81. What this is asking, though, is what number times itself gives you 81? 9. Not divide, really. You just have to think of what number times itself gives you 81. So what number times itself gives you 81. And so the square root of 81 is 9, because 9 times 9, or 9 squared, is 9. And the square root and the square cancel, so that's why your answer is just 9. And you don't have to write the reason why. I'm just trying to show you at least a few times. Yes? Say that again. Say that again. Yes, the second one is 8, because 64, what number times itself gives you 64? Well, 8 times 8 gives you 64. So it's the same thing as 8 squared, and the square root and the square cancel, so it's just 8. And again, this is just extra work to show you why it's 8, but yes, it is 8. If there's a number out front, you ignore it to begin with. So 18 is just out front, but we're just taking the square root of 4. So what number times itself gives you 4? So we're ignoring the 18 for now. 2. So 2 times 2 gives me 4. So the square root of 4 is 2, and now we don't ignore that 18. You're going to multiply those two together, and that'll be your answer. 3. It is 11. 121. 11 times 11 is 121. If you don't know that, then you have to take your list and just start dividing by it. That's why on your warm-up, I had you go all the way to 12. Because I want you to memorize all the way up to 12 what numbers multiply together. Because this was times 10, 10 squared. 11 squared is 121. 12 squared is 144. A lot of teachers memorize up to 15, but you probably won't get that high. Negative 55. All right, 5's up here because people are usually scared of 5 just because it has a fraction. But it's not that bad, because all you're doing is you're taking the square root of the top. So what's the square root of 1? 1. And then what's the square root of 16? What number times itself gives you 16? 4. So 1 times 1 gives me 1, so that's the square root of 1. And 4 times 4 gives me 16. So the square root of 1, so 1 times 1 gives me 1. So my 1's on top. And the square root of 16 is 4 times 4. So it's 4. These are perfect squares because they end up being perfect numbers. Honestly, you can put these in the calculator and it'll give you your answer. Let me show you. I can do the square root of 121 and it'll give me my answer, 11. I can do the square root of 1 over 16 and it'll give me my answer, 1/4. But we also have to know how to simplify non-perfect squares. So like the square root of 24, the square root of 48, well, wrong calculator. And if I put that in the calculator, it will not give me an answer. It will give me a decimal that can't be turned into a fraction, that can't be rounded. Like this number keeps going for a very long time. So you don't want to round because then if you're dealing with like medicine or building or anything like that, you'll be losing part of your number. So you never want to round these. You want to actually simplify them. So we actually need to find the biggest square root that goes into 24. So looking at our numbers, 6, okay, that's high enough for this one. What is the biggest square root that goes into 24? So it can't be 25 because that's one higher. Does 16 divide 24 easily, like nicely? What's 24 divided by 16? 24 divided by 16. Is it a nice number? No, it's a decimal. So then you go to 9. Is 24 divisible by 9? No, it's a decimal. What about 4? 24 divided by 4? No. Yes. 24 divided by 4 gives me 6. So I'm going to break this into 4 times 6. And I chose 4 because that is your perfect square. Guys, pay attention. So I chose 4 because it's the biggest perfect square that goes into 24. It's 4. I tried 9, I tried 16. These didn't work. 1 always goes into every number. But we don't know the square root of 6, but we do know the square root of 4. What number times itself gives you 4? 2. So 2 square root 6. Because that's 4 times 6 gives me 24. Then we can move to 48. What is the biggest perfect square that goes into 48? Might be 4 again. 9. 48 divided by 9. Oops. My delete button. Decimal. 16. 16. 16 and 3. No, 16. 4 goes into 48, but it's not the biggest number that goes into 48. So the biggest, and so if I was to start this question, I would start with 36. 48 divided by 36. Doesn't work. 48 divided by 24, 25. No. 48 divided by 16. So 16 and 3. So yes. So the square root of 16 is 4. So you have 4. And well, you don't know the square root of 3. So that just stays underneath there. Get our numbers a little bit bigger. Divide by 100 obviously isn't true. 162 divided by 81. 2. So 162 divided by 81 gives you 2. And you know the square root of 81. What is the square root of 81? 9. Because 9 times 9 gives you 81. So 9 square root 2. 9 square root 2. So these are all square roots. These are called not perfect square roots. Because if I put them in a calculator, I just get a long decimal. The next ones we just have to do are cube roots. Now, people usually have a little bit more trouble with cube roots just because you're not as familiar with cube roots as you are square roots. So we made the list of cube roots. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed I don't want to tell you wrong. We're not timesing the exponents, we're multiplying. 2 cubed is 2 times 2 times 2. 3 cubed is 3 times 3 times 3. 4 cubed is 4 times 4 times 4. 25. 125. 6 cubed is 6 times 6 times 6. $216. So you can either type out 6 times 6 times 6 or it's just 6 cubed, either way. Then we'll do 7 cubed or 7 times 7 times 7. 8 cubed. I went to 10. Oops, that was squared. 9 cubed. 10 cubed. $343. Yep. Yeah, I just went to 10. You could sit here and do this list all day. $512. And the last two are 729 and 1,000. $729 and 1,000. So with square roots, you say what number times itself gives you that number. With cube root, it's what number times itself 3 times. Gives you the radicand, which is just the number underneath. Mm-hmm. It's on this. These are our last 6 together. Then you can do your delta math. So the cube root of 8. Well, that's a perfect cube. We know it. What number did we multiply 3 times to get 8? 2. Because to get 8, we did 2 times 2 times 2. Or another way to write that is 2 cubed. And the cube root and the cube cancel out. So that's why your answer is just 2. $729 is part of that list too. What number do we multiply 3 times to give me $729? Almost 10, 9. Because this is 9 times 9 times 9. So you got 9. Just be 9. What about -1? -1. What's different about cube roots is that a negative times a negative times a negative, negative times negative is a positive, times another negative is a negative. So yes, you're right, -1. If I asked you the square root of a -9 square root, it is not possible. You cannot take the square root of a negative number. So this is not possible. It's actually called imaginary, and that's getting into algebra 2, which you should see in 11th grade. So this is not possible because it's imaginary. It's actually called 3i, which is imaginary. So there are such things, numbers called imaginary numbers. We're just not going to do it. The only thing I want you to know is the square root of negative numbers you can't do. The cube root of negative numbers you can do. And so these first 3, 10, 11, and 12 are perfect cubes because they came out to nice numbers. But when you get down to 13, 14, and 15, those are not perfect cubes. They would give me these long decimals that I can't simplify. The first 3 you can put in the calculator and it'll give you an answer. 13, 14, and 15 you can't. You actually have to do what we were doing on this, but now with cubes. No. I mean, you would get a decimal, but that answer won't be accepted because I don't want you rounding. So just like we did before on these 3, we want to know what is the biggest perfect cube that goes into 40. So biggest perfect cube that goes into 40, 27. And does it go nicely? So it's 40 divided by 27. I agree. But if 27 goes into it, then that's not 8 wouldn't be the biggest one. $27 doesn't go into it. So then our next one we try is 8, like you said, Kennedy. And 8 goes into it. Whoops. 5 times. And you get 5. So we know the cube root 40 can be written as 8 times 5 because 8 times 5 is 40. And we know the cube root of 8. The cube root of 8 is 2. So the cube root of 8, 2 cube root 5. Yep. All right. If you do not put this 3 here, it's going to say the answer is wrong. Because if you don't put the 3 there, it's an assumed 2, because that's what square root is. and you get a wrong answer. Yes. You can put 2, it's not wrong, but you don't have to. It's just assumed a 2's there. All right, last 2, and then I'll pull up Delta Math so I can make sure you guys are good with that. 500. What's the biggest perfect cube that goes into 500? 10. 10's not a perfect cube. But you said it's not. 343 is the next number on our perfect cube, but we got decimal. A long decimal. So it's not 343, huh? 50, you're trying, 50 goes into it, but you want to try these perfect cube numbers. That's why we have that list right now. If I put it in a calculator, I think this is what you're saying. If I put the cube root of 500, it's not a nice number. It's this long decimal that goes on and on and on and on and on. Let me click on you. So when you don't know, you just have to start taking the number, the radicand is the number underneath your radical, and dividing it by these numbers. So I did 343, and that didn't work. So now I'll try 216, 500. No, that's not a good number. So then 125. That's 4. All right, that's our good number. So equals 4. So 125 times 4. You're taking square root. This is the cube root. The square root of 4 is 2, but the cube root of 4, we don't know. So you don't put a 2? No, we don't know the cube root of 4, but we do know the cube root of 125. What number times itself 3 times gives you 125? 5. But I thought you 4. Yes, 4 times 125. But we don't know the square root of 4, or the cube root of 4. We know the square root of 4. Last one. My trick for negative cube roots just is your answer is going to be negative at the end. So you can just ignore the negative and just have it at the end. So what's the biggest cube root that goes into 16? 8. Nice. So 8 times what gives me 16? 8. 8 times negative. 8 times. Oh, no, that's wrong. It's 4. You're thinking square roots. You're getting square roots and cube roots mixed up. If you don't know, put it in the calculator. What's 16 divided by 8? It's 2. 2. So 8 times 2 gives me 16. And like I said, I'm just going to ignore the negative and put it at the end. I don't know the cube root of 2, but I do know the cube root of 8 is 2. And that's the cube root you're going to see the most. The cube root of 8 is you're going to see the most. So that's your answer. And that ends your notes for today. and then we'll go to Delta Math and work some of these. I just want to see the first few because it's like a guided practice one, and some people have trouble with this. Okay, so it says square root of 240 on mine, and so I need to know the biggest square root that goes into 240. So I'm looking at my square root list and looking for the biggest number that goes into 240. So 240 divided by 144, no. 240 divided by 121, again, no. 40 divided by, I'm just going down this list, 100, no. 240 divided by, I tried 100, I tried 81. I'm getting there. Running out of numbers. Oh, 64, not 61. No, so no. Finally, 16. Took me a while, but I got there. 240 divided by 16 gives me 15. So I did 240, I divided it by 16, and I got 15 by that. And then I know my square root of 16 is 4. Not yet, no. And so then I tried it, and then that's my answer. So that is what you're doing. And it says fastest path because there is the slowest path. If you don't find the biggest square root, then you just have to keep going and going and going, and it takes a while. Try one more problem. So if I start at the bottom of my list, but if you start at the top of your list, 224 divided by 4, the 4 and 56 work. 4 and 56 work. Try it. I know the square root of 4 is 2. Don't know the square root of 56. But square root of 56, you have to go again. So if you don't find the biggest square root that goes into this number, 224, then you have to keep going. Now I have to figure out what's the biggest square root that goes into 56. I think it's 8. 8 goes, oh, 8's not perfect square. That's perfect cubed. 4 again? 4 again. So 4 and 14. What's that? Square root of 4 is 2. And then I'd have to multiply the 2 and the 2 on the outside. And this is the long way to do it. So you know there's a short way to do it. The square root of 224. 224 is divisible by 16. 16 times 14. 16 times 14. And then the square root of 16 is 4. So if you don't find the biggest square root, it's going to take you a little bit longer to get down to your answer. All right, so I'm going to post it so you have it.